Errare humanum est. To err is human, even though no one likes to make mistakes. But in the healthcare setting, mistakes could be a fatal word. When dealing with human life, what we call an error could signify death of a patient. The healthcare industry is a demanding, complex, and fascinating field. Every day we hear stories of patients who could save their life thanks to the set of skills of medical teams and the recent technological achievements. But there is also another side to the story: medical errors. In her article for the Washington Post, Ariana Cha reported that a new study by the Johns Hopkins University researchers found that medical error is the third leading cause of death in the United States, after heart disease and cancer, with 251,454 annual deaths. Cha, 2015. Will not it be urgent to eliminate errors? The complexity in the healthcare system is such that it could be prone to error, from adverse drug events, delay in treatment, inadequate monitoring after a procedure, to improper medication dose. In the interest of improving patient safety, strictly scientific improvement methods have been required to increase quality service in the healthcare industry, and at the same time, to compete in the new global marketplace. Lanham and Maxon Cooper assert that Six Sigma structured methodology and sophisticated statistics tools make a powerful approach to reduce an error and enhance patient safety. Adding that Six Sigma is the catalyst needed to successfully combine quality, cost, and patient safety. Langa and Maxon Cooper, 2003. The defect reduction system of Six Sigma makes it the perfect tool to target the need for performance optimization in the healthcare industry, specifically focusing in medication error. Let's talk about Six Sigma name's origin. Sigma's lowercase Greek letter refers to the standard deviation. As we recall, standard deviation is how spray numbers are, and its formula is the square root of the variance. But what is the variance? The variance is the square differences from the mean, which is the ideal point. At Six Sigma, the top quality measure 0.002 failures will happen each 1 million chances. So it targets a defect rate at 3.4 per million or less. Gotch and Davis, 2016. Six Sigma purpose. In the Six Sigma video, Introduction to Six Sigma, it points out that Six Sigma original goal was to increase profits by making customers happy, by reducing variation, making process more predictable, and providing consistently good products or services, and reducing or eliminating defects and rewards. It also works as a measurable way to track performance improvement, to allow for focused attention on all levels in the organization, to target the error, and allow better efficiency and effectiveness of processing. What's the Six Sigma origin? Six Sigma's approach was introduced by the Motorola's engineer Bill Smith. It was based on the work of the Total Quality TQM pioneers, Edward Deming and his Total Quality approach, Joseph Juran's Pareto principle, Zero Defects advocate Philip Crosby, and Genichi Taguchi's Robust Design method. A year later, after its implementation, Motorola won the Malcolm Baldrige National Quality Award. And from that day, large companies such as General Electric, Hewlett-Packard, Allied Signal, Johnson & Johnson, Ford, Nissan, Honeywell, and others decide to incorporate the Six Sigma management strategy into their own management systems. Six Sigma DMAIC quality method. DMAIC method is the most common methodology used by Six Sigma improvement teams. It involves 5 steps. Step 1, define. What is the process? What is wanted? What is the goal? Define the project, process, and scope. Collect background information and customer requirements. Step 2, measure. Measure the current situation and gather information on the current situation. Collect relevant data to have a clear understanding for the improvement effort. Step 3, analyze. Why the process is failing? What are the root causes of the error? Through this step, we go deep into the cause and effect relationship, and we confirm it with data. Analytical tools such as Pareto analysis, fishbone diagrams, and process flow diagrams are used to identify necessary design and process modifications performance objective. Step 4, improve. Develop, try out, and implement solutions that address the problem or defects found, and then use data to assess results for solutions and implement the improvements. Step 5, control. Maintain the level achieved, anticipate future improvements, and preserve process learned. Overall goal. Patient safety is the #1 priority for any healthcare provider. Thus, the ultimate goal of any healthcare provider is to eliminate error, and so the application of an error reduction method will become a prerogative. Six Sigma, a disciplined, data-driven approach for eliminating errors by using the define, measure, analyze, improve, and control DMAIC method could be an efficient and effective solution to help healthcare professionals improve medication delivery and performance, and finally, to render a high quality of service.